Okay, in this video we're going to take a look at the simple collision jointing method where we're going to have this ball falling, rolling along this box. We're going to create a bunch of particles on this box, and then wherever this ball hits one of these little objects on here, on this plane, it's going to go ahead and create a joint, and then those are going to stick onto that object. So we'll go ahead and get started. Pretty simple again. We're going to go ahead and use the standard SC basic. Have a collision environment is our plane there. I should really add a group setting to this black box. The one thing, of course, to remember that anytime you have an object particle, and if you're using tracking, and then as soon as you switch group, whether it's here at birth or later on in the rule, that tracking is going to get broken, and the object's no longer going to follow its animation. Okay, so that's going into our collision environment. We can hide that, and then we'll go ahead and pick this particular object here as our sphere, the objects group. And we're actually also going to create another group called, we'll call it debris. We'll show the mesh and dots, and we'll make it kind of a brownish debris color. And we'll go ahead and use a generator, and we'll call it, birth node surface. And of course we hid that box, so let's pick that again. So it's going to create a bunch of particles all over there. We're not going to worry about that right now. It's going to go ahead and create some on the surface for us, which is the top surface, which is fine. So we'll create this. Let's modify our size and our scale. Change that Z again, get them nice and flat, and not so much variation, and a little bit bigger or smaller. Let's see. Okay, well, I think we're going to need more of them. Okay, so this is going to be pretty fast and simple. What we're going to do is this ball is going to be obeying gravity, and so it's going to go ahead and fall. It would be helpful if we hid that, and then let's go ahead and show our meshes there. Okay. Okay, so the ball falls, hits, and kind of rolls over that stuff, and then, of course, drops off. So what we're going to do is we're going to set up just a really simple jointing system based on when a collision occurs between specific particle groups, between objects and the debris. So if there is a collision between those two and the number of joints between those two specific particles is less than 1, then we'll go ahead and create a joint, because we don't want to create too many joints during those collisions. So first thing we need is an in-group test. We're going to test, hey, is the first particle group, and remember the way this SC works is collision particle A is always higher up in the list here. So we want to know if there's a collision between objects and debris. So particle A, we're going to say, is this in the objects group? And then particle B, are you in the debris group? Okay, if both those are true, but not just that, we actually want to do a joint counter, and we want to test, hey, between that particle and this particle for SC, don't forget to set your collision setting there or nothing's going to work. Count the number of joints between those two, and if that number of joints, if that value is inside 0, meaning is it 0, and if all these conditions are true, then we can go ahead and create a joint. So we'll go ahead and add our AND, because we want to evaluate all of them and make sure all of them are true at once. And then finally, the SC joint. So we'll create that from that particle to this particle, and it gets a little bit interesting. We get to, well, let's control when this on occurs. It's going to be based on that AND. Our joint is to specify the SC. Let's do spherical, that's fine. But the world position, where we create that actual joint, We don't just want to do it in between averaged positions again anymore, but we have the handy information here of, hey, there's a collision position. Let's just go ahead and use that. Okay, so let's see what we get. So look at that, it's starting to pick them up. Anywhere there's a collision, it goes ahead and grabs it. And because they're spherical joints, it is, okay, let's go ahead and get a better view. Because they're spherical joints, those things will kind of move around the debris on the object, so then they're not fixed in space. Let's go ahead and actually make it fixed, and we can kind of see that behavior difference. Let's check edit on the fly turned on. And from our last video, something that we mentioned was that the joint stability and performance of joints, they will be more stable and more accurate the more samples you have. So I generally recommend 4 samples per second. I'm sorry, 4 samples per frame. And here we are on film time, so 4 samples per frame turns into 96 samples per second. So that's going to be a little bit slow. This isn't all that complex. You know, we're going to be able to get away with per half frame or even per frame, but we'll use per half frame just for a little more accuracy. And so now with the joints being fixed, we can see that we kind of get, yeah, these things definitely kind of affecting that behavior more. They're not bending down in here anymore. And then boom, okay, so there's a stability issue. You saw that happen, I think. Let's go ahead and 96 samples per second might fix that. Let's go ahead and just record this out. Say cache record right there, and we'll just let that go. So I'll be right back. Okay, well at 96 samples per second, we get a little bit more stable behavior. It does not kind of go crazy and fly out there. Although we do kind of get some weird stuff with a couple of these particles just kind of floating up. So let's see what we... it's these two guys right here. So maybe they got pulled up with the collision. Not entirely sure there. But anyway, just remember, for more stable joints, try to get your samples per second or samples per frame. It's kind of easier to think of. 4 samples per frame will be much more stable. But okay, so this is just a pretty easy way to go ahead and create joints on the fly during a collision using SC's outputs to test, hey, are my 2 objects collision objects in specific groups, and if they are, and if their joints, the number of joints already between them are 0, then we'll go ahead and create that SC joint for them. Okay, let's move on.